You are currently the only person in this conference.
Good evening, everyone.
Good evening, sir.
Good evening, Kritika. Good evening, Saloni.
Sir, I raised one query to Jatin, sir. You must have received it regarding the vaccine.
Yes.
Yeah, sir, I still have a doubt on it.
Yes, please go ahead.
Sir, actually, you said on a greater perspective, if we'll see the benefit for the general public, right?
Yes.
So I just wanted to know, still the right of the innovator will exist or not?
See, the degree of breach in the innovator's right, that will be of larger degree. I told you that there is a balance between the innovator's right and the rights of the general public. So in the
Yes,
case of COVID-19 pandemic, this is not a normal situation.
exactly.
Okay, so in this situation, the governments, they will encroach on the rights of the innovators. Okay, they can completely take over the innovators' right, but they know that that will hamper innovation. So they will encroach upon the innovators' right to a larger extent because they have to serve the public. Obviously,
So
saving
he will
lives.
not be so innovator not will not be paid the financial benefit and all something like those who, whatever he had spended over his research and all while
The
getting out with
benefits
the
will be
vaccine and the 20 years patent right.
no, for the COVID-19 pandemic, the situation will be different. Okay, here it is more of philanthropy. We have to save the humanity. Okay, the first target of the government and the international organization NGOs, it is to protect the public.
Okay.
Okay, तो फाइनेंशियल बेनिफिट्स पे अगर इनोवेटर्स के कुछ एनक्रोच हो जाते हैं तो उसके ऊपर कोई ध्यान नहीं देगा. ओके, अभी जितनी भी कंपनीज हैं अगर वो सर्च कर रही हैं वैक्सीन को, इट इज फॉर सेविंग द ह्यूमैनिटी.
Okay, sir.
ओके,
Thank you, sir.
वेलकम सलोनी. So we were doing these polar vortex and jet streams, and I told you in the last class that the polar vortex, it is responsible for extremely cold conditions in the upper part of the atmosphere, and because of those cold conditions the polar stratospheric clouds, they are formed. And when the polar stratospheric clouds are formed, then from the inactive reservoir of chlorine, okay, the chlorine gas releases from the inactive reservoir, and this chlorine, it dissociates in the presence of sunlight in the single chlorine atom, which destroys the ozone. यहां पे किसी को कोई प्रॉब्लम है? See, in the last class, guys, is there any problem with this class? Are you getting my voice?
Yes, sir.
Okay, fine. So I told you about the pressure belts on the planet Earth, and these pressure belts, these are due to the rotation Good evening, Aditi. So these pressure belts, these are due to the rotation of the earth and the heating by the sun. Okay. I also told you that sun remains between the tropics. As the earth moves around the sun, the apparent position of the sun, the apparent overhead position of the sun, it remains between the tropics all around the year. And for this reason, the equator, it receives the direct sunlight. Okay, because sun remains mostly the overhead, so intense heating is there in the equatorial region, and because of that intense heating we have a low pressure zone at the equator, and this low pressure zone, it is known as intertropical convergence zone. Okay, at 30° we have the high pressure zone. Okay, on the 30° north and south we have the high pressure zone, and again we have a subtropical, we have a polar low pressure belt, and then we have the polar high. So winds blow from the high pressure towards the low pressure. Okay, this is one thing. So we have these belts, and winds they blow from high pressure towards the low pressure. Okay, so these winds, they are deflected, they are deviated because of the rotation of the earth. Ideally, the wind should have blown from the horse latitudes, from the 30° pressure belt towards the equator. Okay, but they are deviated slightly to the right. They are deflected to the right. Yes, Nikhil?
Sorry, sir, by mistake I.
Okay, Nikhil. So in the northern hemisphere, the deflection is towards the right. If any object is moving in the northern hemisphere, then it will be deflected towards its right because of the rotation of the earth. So this effect is known as the Coriolis effect. Okay, so here the winds are deflected towards the right. Winds are deflected towards the right. Okay. And in the southern hemisphere, the winds, they are deflected towards their left, because an apparent Coriolis force, it acts on the moving particle, and particles are deflected because of action of that force. I also told you in the previous class that the reason for the winds, there are three reasons. We have the pressure gradient force, and we have the Coriolis, and third one is friction. Okay, do you remember these? So the winds that are blowing near the surface of the earth, these are because of these three forces: the pressure gradient force, the Coriolis force, and the friction force. Now, who will tell me what is this pressure gradient? Who will define the pressure gradient? Difference in pressure. Okay, Subhajit, be more specific. I need specific answers.
Sir, it is the grid which controls the pressure of the wind, like becoming high or low, it controls the pressure.
No, Nikhil. Soumi is saying the difference between pressure at two regions. So wind blow from high pressure to low pressure. Okay. Okay, see gradient. Yes, Deep is right. It is the pressure difference per unit length. How the pressure changes with distance. Pressure gradient measures how the pressure changes with distance. That is the pressure gradient. Okay. The more the gradient, okay, the more is the pressure gradient force. See these horse latitudes, they have a specific name, horse latitude, because of a specific reason that you will learn in geography. So this horse latitude, it is a high pressure zone. Okay, but winds, in this zone, in the 30° north, the winds, they do not blow at a greater pace. The pace of the winds, it is very low. Why it is low? Because the pressure gradient is low. Though overall the pressure at the horse latitudes, it is very high. Okay, the pressure is high, but the pressure gradient is low. And because the pressure gradient is low, the winds, they do not have great speeds. Okay, so the winds near the surface, they are blowing because of the effect of three forces. One force is the pressure gradient force, and one is Coriolis force, which is due to the rotation of the earth. And the third force is frictional force, the frictional drag of the earth's surface. And because of the combined effect of all these, we have these pressure belts, and this is the wind system of the earth. And these winds, they blow throughout the year. Okay, this is the simplified version of a complex reality. I told you in the last class that the complex reality is studied by the supercomputers, by the atmospheric models that are made by the supercomputers, that are simulated by the supercomputers. So the actual study of the atmosphere, it is done with the supercomputers in meteorology. And this is the most simplified version of the complex reality. So this equator, suppose this is the equatorial zone, and we have low pressure at the equator, and winds are converging at the equator. The winds are converging at the equator and they are rising up. So this is a zone of convergence. A low pressure area is a zone of convergence. The winds are rising, and in the upper part of the atmosphere, they are diverging. So I also told you that the low pressure in the lower portion of the atmosphere, it is supported by high pressure in the upper portion of the atmosphere. Okay, low pressure below is complemented by the high pressure in the upper region. So this I also told you in the last class, and here the cell is completed. This cell is known as the Hadley cell between the equator and the 30° latitude. And another cell is the Ferrel cell, and one is the polar cell. Okay. So the winds are converging at the equator and they are rising up at the equator, and in the upper portion of the atmosphere, they are diverging. So high pressure zone is the zone of divergence. Aman, see, the equatorial zone, it is the zone of convergence. The winds are converging here. And to maintain the low pressure, they are rising. That is one reason. They are rising to maintain to make way for the incoming air. And second reason is the heating by the sun. Just as a hot air balloon rises in the atmosphere, in a similar way, any column of air is rising, okay, is rising in the equatorial region. So the winds, they are converging at the equator and they are rising. So one reason is they are rising because they have to make way for the incoming air, and they are rising because the hot air, it always rises up. सभी ने एग्जाम्पल देखा होगा, अगर हम एक प्लास्टिक की बॉल को पानी की बाल्टी में डुबोएंगे, देन इट विल राइज अप. वो राइज क्यों करती है? बिकॉज द डेंसिटी इज लेसर देन द सराउंडिंग एनवायरमेंट. वाटर की डेंसिटी ज्यादा है और उस बॉल की जिसके अंदर एयर भरी हुई है उसकी डेंसिटी कम है, सो इट विल राइज अप. In a similar fashion, any column of air, it has lesser density than the surrounding environment, so it rises up in that environment. Yes, Nikhil, the air becomes hot due to the heating of the sun. Okay, so at the equator, the air is rising up. It is making way for the incoming air, and it is rising also because of the heating of the sun. And in the upper part of the atmosphere, the winds are diverging. Okay, because winds, they cannot go beyond the tropopause. They cannot escape the troposphere. That is a matter of geography. They cannot escape the troposphere. So the winds will rise up to a height where they can rise, and then they will diverge. So winds are diverging in the upper part of the atmosphere. And the zone of high pressure is the zone of divergence. The winds are diverging at the high pressure zone. Winds are diverging from the high pressure zone. And to maintain that high pressure, the air from above is coming in. Okay, so this is how the circulation gets completed. We have these cells: Hadley cell, Ferrel cell, and polar cell. You will study them in the physical geography, and I have gave you pretty good idea about what these cells are. Is it clear, Aman? Okay. Nikhil, you are asking if winds are unable to escape the troposphere, how are CFCs able to reach the stratosphere? See, CFCs, they have a larger lifespan. Okay, they remain stable in the troposphere for quite a long time, and there is always a mixing. There is not a watertight separation between the troposphere and the stratosphere. Okay, the currents, they do mix, and CFCs, they leak in the stratosphere. See, Aman, if you look at this, let us look at the Ferrel cell. From the horse latitudes, the winds are moving towards the polar low pressure belt and towards the equator. So by the same mechanism, the winds are moving towards the polar low pressure belt, and there they are rising, and again in the upper part of the atmosphere, winds will diverge. If the low pressure is near the surface of the earth, we have a high pressure in the upper part of the atmosphere, and winds will diverge. It is similar to the Hadley cell, the cell between a high pressure belt and a low pressure belt. It is almost the same. Polar belt has high pressure. From the polar areas, we have low pressure at this polar front.
So there is polar front ना
Yes.
यहाँ पे pressure high है.
Yes.
तो I am asking, नहीं low लिखा हुआ ना L.
Low pressure. हाँ, low pressure.
तो why there is low pressure?
See, these pressure belts, I told you, they form because of the rotation of the earth, because of the sun's heating. Okay, and this temperate low pressure belt, or the polar front, it is the region of mixing of two air masses. We have a colder air mass which is coming from the polar region, and we have warmer air which is coming from the tropical areas. So this is the zone of mixing of two air masses. So it is a combined effect of three things. One is the rotation of earth, two is the differential sun's heating, and third is a front is formed. A front is basically where the two air masses, they mix together. Okay, and warmer air is always lighter, it always rises up. जैसे ही cold air and warm air, they will meet, the cold air is denser, वो हमेशा नीचे रहेगी, and warmer air, it will always rise up. And the equator, the warm air is rising, तो pressure वहां पे क्या था? Low pressure. इसी एनालॉजी से समझो, warm air is rising at the polar front, at the temperate low pressure belt. So we have a low pressure at the temperate low pressure belt or the polar front, because the warm air is rising there. Okay. So वैसे ज्योग्राफी में ये होना था, लेकिन ज्योग्राफी में भी इतना ही है, अभी हो गया तो अच्छी बात है. So I also told you that the lower air circulation, it is connected to the upper air circulation, and in this diagram, it is a very simple model. Okay, this is a very simple model of the complex reality. So in actuality, in the upper air circulation, the situation is not same as shown in this diagram. In the upper air circulation, we have the jet streams. And I told you that in the case of jet streams, we have the PGF, we have the Coriolis force, but we do not have the friction. The friction is absent in the upper portion of the atmosphere, and we have only the two forces. The winds are blowing under the balance of the two forces. One is the PGF and one is the Coriolis. So in the upper portion of the atmosphere, we have the wind circulation known as the jet streams, which are high speed winds blowing in the upper portion of the atmosphere, and they blow under the balance of the pressure gradient force and the Coriolis force. And these winds, they blow parallel to the latitude. If this is my 30-degree latitude, then the winds will blow parallel to the 30-degree latitude, and they will encircle the globe. And these winds, they blow at very high speed. क्योंकि friction नहीं है. जब भी friction नहीं होगा, then speed will be greater. There is no one stopping them in the upper portion of the atmosphere, so they blow at great speed. Okay, so in this portion, we have shown that a polar vortex is formed in the polar region, and this polar vortex is protected by it. Yes, Tisha?
You are now unmuted.
Sorry?
You are now unmuted.
So there is no doubt
Okay.
it was connected.
Okay, it's okay. So these jet streams, the polar night jet streams, they are protecting this polar vortex. Since there is a low pressure in the polar vortex, the warmer air from the upper part of the equator, it should come and it should mix with the polar air in this polar vortex. But the jet stream is protecting the polar vortex. Okay, it does not allow the mixing of air, the polar air and the equatorial air. And because of this, the temperature inside the polar vortex, they remain low. And these are essentially the enabling conditions for the formation of polar stratospheric clouds. And it supports the further depletion of ozone. यहां तक किसी को कोई प्रॉब्लम? अगर एक बारी फंडे अगर समझ में आ गए तो फिर कोई इशू नहीं होता है ना. तो स्टार्टिंग में 1000 बार टॉक के चीजें समझ लो, बाद के लिए आसानी हो जाएंगी. यस सर. फिर
sir, these jet streams, sir, these winds, sir, jet streams, sir, they only are present over the poles, sir. They are present.
No. Actually, we have these are the polar jet streams, and we also have the equatorial jet streams. Okay. We have jet streams even at the equator and in middle latitudes also. So jet streams are there. Yes, Nitil, I will explain it. See, the more the temperature contrast, the stronger will be the winds. Okay, Ruxana, what should I explain? The jet streams or the polar vortex? Polar vortex. Okay, Ruxana. So in the polar region, in the lower part of the atmosphere, we have high pressure. Okay, we have a polar high pressure belt. In the polar regions, this portion, we have high pressure in the polar region. So in the lower part of the atmosphere, we have high pressure. This is the situation at the ground level. And in the upper part of the atmosphere, we have low pressure. अभी पिछले स्लाइड में समझाया था कि अगर ग्राउंड पे हाई प्रेशर है तो अपर एयर में उसको सपोर्ट करने के लिए लो प्रेशर होना जरूरी है, और अगर नीचे लो प्रेशर है तो ऊपर हाई प्रेशर होना जरूरी है. ओके, because there is a low pressure situation in the lower part of the atmosphere, in the poles we have a low pressure in the upper part. We have a high pressure in the lower part and a low pressure in the upper part. So this low pressure region, this is the polar vortex. Okay, because this is the polar region, still the condition in the polar vortex, they are very cold, and they support the formation of polar stratospheric clouds, for which the temperatures are needed minus 83 degrees Celsius. Okay, so this low pressure zone, polar vortex, it is encircled by the jet streams. If you look at the North Pole from the top of it, okay, then you will see that jet streams, they are moving anti-clockwise around this low pressure zone, which is the polar vortex. Imagine you are standing at the top of the North Pole and you are watching it from above. So there is a low pressure situation in the upper part of the atmosphere, and that low pressure situation, it is encircled by a jet stream which is moving in the anti-clockwise direction as you are seeing it from the above. आप अगर ऊपर से देख रहे हो अर्थ को and North Pole आपके नीचे है, then you will see that jet streams, they are moving in an anti-clockwise fashion and they are protecting this polar vortex. तो इन jet streams की वजह से the warmer air from the equatorial areas, it cannot come and mix with the cold air in the polar vortex. So polar vortex, it is helpful in sustaining the colder conditions and the formation of polar stratospheric clouds. And if polar stratospheric clouds are formed, then the ozone will destroy. Okay. Is it clear now? ओके, अगर नहीं हो तो कोई बात नहीं, दोबारा पूछ लेना. आई विल एक्सप्लेन यू टुमारो. ओके, दैट इज नॉट एन इश्यू. समझना ज्यादा इंपॉर्टेंट है.
Sir,
यस निखिल.
sir, if human activities are reduced or if they are completely stopped, then this polar stratospheric clouds, they won't form, no, sir?
The polar stratospheric clouds will not form if the human activities are stopped. So Nikhil, see these polar stratospheric clouds, they are a natural phenomena. Okay, they are a natural phenomena. They are a natural part of the atmosphere. Okay. So one more thing I told you, that these jet streams, these are due to PGF. These are due to the Coriolis. And if the temperature contrast, if the thermal contrast is stronger, then the jet streams, they are stronger. Thermal contrast means the temperature difference between the polar region and the equatorial region. If the thermal contrast is stronger, okay, then the jet streams, they will be stronger. And if the thermal contrast is less, so that is why these jet streams, they are very strong in the winters. Because in the equatorial region, the incoming solar radiation, it will not change much. But in the polar region, it will decline by a huge amount. So there is a huge thermal contrast during the winters. So the jet streams are stronger. So when the thermal contrast, it is not very strong, then the jet streams, they do not blow with that much intensity and with that much consistency of direction. Thermal contrast जैसे ही कमजोर होगा, तो jet streams, they will start to meander. So this wavy formation is the meandering of jet streams. पहले consistently एक ही direction में वो move कर रही थी, लेकिन अब they will form this wavy kind of structure. And because of this phenomena, the colder polar air, it reaches the southern part of the United States. Okay, ये बेसिकली पूरे यूएस को कवर कर लेती है. And because of this phenomena, the conditions, the winters, they are very, very harsh in the United States. Whenever the polar vortex this breaks, okay, we have the very severe winters in the US. You must have seen, I guess, this January or the last January, the winters, they were very severe in the United States. Okay, so the breaking of the polar vortex, it is also related to the severe winter outbreaks in USA, Canada, and in the Europe. Okay. And in the southern hemisphere, because of the weakening of the jet streams, the ozone poor air. No, Nikhil, these are not related to hurricanes. Hurricanes, they are a phenomena of the lower portion of the atmosphere. Although the hurricanes are also connected to the upper air circulation, but majorly the hurricanes, they are a phenomena of the lower portion of the atmosphere. And hurricanes are because of the differential warming of the ocean water and the thermal contrast with respect to the land. Hurricanes, they are a different feature. You will study in geography. Hurricanes, they are basically tropical cyclones. In the southern hemisphere, when the jet stream meanders, because of the meandering of the jet stream, the ozone poor air, it reaches to New Zealand and the southern portion of Australia and southern portion of Chile. So because of the breaking of the polar vortex, ozone poor air, it reaches the New Zealand, Australia, and southern Chile, and the ultraviolet rays, ultraviolet B rays, they will reach the surface. They will reach the land surface, and there is an increased incidence of the sunburn and the problems of skin cancer. Okay. अब यहाँ पे किसी को कोई प्रॉब्लम है? Second point. This point. Okay. As the jet streams, they become weaker. They adopt a meandering path. See, there will be a consistency of direction and speed when the thermal contrast is stronger. And as the thermal contrast, it gets weaker, the jet streams, they also get weaker in speed and in direction as well. जैसे ही थर्मल कॉन्ट्रास्ट कम होगा तो डायरेक्शन की कंसिस्टेंसी भी नहीं रहेगी, ना ही स्पीड की रहेगी, एंड दे विल अडॉप्ट अ meandering path. Okay, in this diagram, this is explained. Wavy polar vortex when the thermal contrast is not stronger. Yes, Subhajit. It can even break during the winters. It can even break during the winters if the thermal contrast is not very strong. But generally during the spring. Okay. So can anyone tell me that what is the benefit of UVB rays? We have learned that UVB, they are very harmful. Is there any benefit of the UVB?
Sir, I think they provide us with vitamin D. Our body needs vitamin D.
Yes, Nikhil. Yes, Nikhil. They help in the formation of vitamin D. Very good, Nikhil. You guys were typing something. Why did you stop? Go ahead with your questions. You don't have any questions? Okay, then we shall proceed. See, we have in the mains examination GS1, GS2, GS3 and GS4. Okay, कौन बताएगा GS1 के अंदर कौन कौन से सब्जेक्ट हैं? History and geography. Very good.
History, geography, art and culture.
Yes, Disha. So GS1, it consists of history, geography, and history means Indian history and world history as well. We have art and culture, and we have the society. Okay, Indian society. So GS1, it is mostly static. And in the GS1, you can prepare it from the previous year question papers because it is mostly static, and you can do the last 6-7 year question papers for the GS1. And for the GS1, you can prepare even now because the questions that will be asked, they will be static in nature, and you can score very good marks in the GS paper 1 because things are very predictable. Okay, the dynamic portion is very less in the GS paper 1. Similar is the case with GS paper 4. We have ethics in the GS paper 4. So you have 250 marks from the ethics. Okay, so this portion, it is also not linked to the current affairs. This is more or less static. So you can prepare these subjects beforehand. But this GS paper 2 and GS paper 3, they are very dynamic. In the GS paper 2, what we have? We have the polity and international relations. Okay. Political science and international relations. So this portion, it is also very dynamic. So GS paper 2, it is to be prepared from the newspapers. The 60 to 70% of the preparation, it is the issue-based preparation. Whatever is happening around the world, whatever is happening in Indian polity with the Supreme Court, it will be covered in GS paper 2, and it is very time-consuming. In GS paper 3, we have Indian economy. What else? Environment and ecology. We have disaster management. Yes, we have the science and tech. Okay, what else? We have the internal security. Economy in itself, it is a very big subject. Okay, environment and ecology, it is also very big, but in comparison to economy, it is not that big. So we have disaster management and science and technology. It is also mostly open-ended. So this is the most dynamic paper of the UPSC preparation. और इसके अंदर आप 3, 4, 5, 6, 7 कितना भी इसमें आप टाइम इन्वेस्ट कर सकते हो. Okay, and you cannot be sure of good marks. So these are only 250 marks, and time investment, it is very huge. Okay, you have to study separately economy, you have to study environment and ecology, disaster management, internal security, and science and tech. So invest your time judiciously. If you will invest more time in the GS paper 1, the similar amount of time in the GS paper 1 and in the GS paper 4, the chances of scoring very good marks, they are high. Okay, so when you are doing time partitioning, you have to do it accordingly. Otherwise, whole year you can read this Indian economy, environment, science and tech. Okay. But by relatively lesser efforts in GS paper 1 and GS paper 4, you can get very good marks. This is only 250 marks, but GS 1 and ethics, it is 500 marks. So there has to be a balance while you are preparing for the mains examination. And since you are not in the prelims mode as of now, okay, the prelims is in June 26 or 27. So you should prepare according to a plan. How much time you are investing in which subject. So the international community was making efforts to phase out these ozone depleting substances. Okay, so that the ozone hole, it can repair itself. So in the 1985, under the aegis of UNEP is again under the United Nations systems, and UNEP is basically the voice of the environment, in the United Nations system. UNEP is the voice of the environment in the United Nations system, and this Vienna Convention, it was held under the aegis of UNEP. And this convention entered into force in 1988. So under this Vienna Convention, the nations, they took voluntary commitments to phase out the ozone depleting substances. Ozone depleting substances, basically the CFCs, okay, and all other categories of the ozone depleting substances. And there was the voluntary commitments by the countries. There was no legally binding commitment by any country. कंट्रीज वहां पे आई और सभी ने अपने वॉलंटरी कमिटमेंट्स वहां पे मेंशन कर दिए कि हम इतने ओजोन डिप्लेटिंग सब्सटेंसेस डिस्ट्रॉय करेंगे या यूज करना कम कर देंगे, और वॉलंटरी कमिटमेंट्स करके चले गए. बाद में उनको कोई फुलफिल कर रहा है या नहीं कर रहा है उससे मतलब नहीं है. कमिटमेंट करके चले गए, कोई अगर फुलफिल नहीं भी करता है, सो देयर इज नो पेनल्टी इफ एनी कंट्री डज नॉट फुलफिल इट्स वॉलंटरी कमिटमेंट्स. So that is the meaning of no legally binding goal. There was no punishment if you do not meet your targets. And this is the first universally ratified convention. सारे countries एक साथ बैठे, उन्होंने decide किया कुछ that we have to phase out the ozone depleting substances, and every country has ratified this convention. Now there is a difference between signing and ratification. किसी ने पूछा नहीं है कि सर साइनिंग एंड रेटिफिकेशन में डिफरेंस क्या हुआ? या 3 क्लास करके थक गए? बैक टू बैक क्लासेस हो रही हैं. No, Disha, ratification is not unanimous. Yes, Aman. Aman is correct. See, when we are signing any agreement, when India is signing any agreement, then the dignitaries, the head of the country, he can sign any agreement with any foreign country. But ratification is different. Ratification is done by it is a very formal procedure. All the details of the agreement, the government institutions, they will go through it. The ministries, they will go through all the details of the agreement. The parliament will go through the details of the agreement, and then they will decide whether they want to really get into that agreement. So ratification is when the government of the country and the parliament has formally agreed to the agreement. That is ratification. एक बार रेटिफाई कर दिया, रेटिफाई करने के बाद वी आर बाउंड बाय दैट एग्रीमेंट. अगर हम साइन करके आते हैं सिर्फ, तो merely signing an agreement does not mean that we are legally binded to it. Yes, people, ratification leads to a legally binding obligation under the international law. Absolutely. Ratification means सोच समझ के हमने टर्म्स एंड कंडीशन को एग्री किया है. ओके So this is the first universally ratified convention. And parties in this convention, they established the global monitoring and reporting rules. Okay, so the countries decided that we will monitor the amount of ozone depleting substances that are emitted in the atmosphere, and we will develop the reporting rules, the mechanism by which the countries, they will report how much ODS they are releasing in the atmosphere. So details generally जो भी हमारे हेड ऑफ द कंट्रीज हैं वो सिर्फ एग्रीमेंट साइन कर लेते हैं और बाद में फिर डिटेल्स जो भी डिप्लोमेट्स हैं वो उनको तैयार करते हैं. ओके, सो दिस वियना कन्वेंशन इट क्रिएटेड अ ब्रॉड फ्रेमवर्क फॉर द फ्यूचर एग्रीमेंट्स. ओके, तो जो क्वेश्चंस अब तक पूछे गए हैं यूपीएससी में या बाकी एग्जाम्स में, वो सिर्फ इतने ही आते थे कि वियना कन्वेंशन इज रिलेटेड टू, सो इट इज रिलेटेड टू द ओजोन डिप्लीशन. And the next is the Montreal Protocol. So Montreal Protocol, it is the next step after the Vienna Convention. So this Montreal Protocol, it was signed in 1987. Again, it is with the United Nations system. And since Vienna Convention, it was not successful. When the things are voluntary, the people, they do not met their targets. Okay. So this Montreal Protocol, it was a more formal agreement and it entered into force in 1989. And it is also a universally ratified convention. And difference from the Vienna Convention is that it involves legally binding commitments. Okay, if you will not follow your targets, then you will be punished for it. There will be some punishment kind of things. So under this treaty, we have the phase out plans for both the production and the consumption of the ozone depleting substances. So there is a phase out plan for both. One thing is production. No ozone depleting substances, it will be produced, or there will be a reduction in the production of ozone depleting substances. One commitment is this. And second is the countries, they will not use or they will decrease the usage of ozone depleting substances. So it is related to production and the consumption of the ozone depleting substances. It is related to production and consumption. And this treaty, Montreal Protocol, it is a very successful treaty. The ozone hole, it has shown signs of recovery, and it is showing the signs of recovery, and it is expected that by 2050 the ozone layer, it will recover itself. Okay, it will recover itself completely. So this was a very successful treaty, and the parties to the protocol, they meet once every year. The parties to the Montreal Protocol, they meet once every year. अब मुझे कौन बताएगा where is this Montreal?
You are now unmuted.
Canada.
Yes, very good, Disha. Yes, Soumya, Montreal it is in Canada. But there was one drawback of this treaty. Montreal Protocol का एक ड्रॉबैक है. Though it was very successful, but there is one drawback of this treaty. See, this treaty has no roadmap to eliminate the existing banks of ozone depleting substances. अब तक जो भी ओजोन डिप्लीटिंग सब्सटेंसेस हम प्रोड्यूस कर चुके हैं, ओके, एक बार प्रोड्यूस कर दिए, देन सोर्सेज ऑफ दीज ओजोन डिप्लीटिंग सब्सटेंसेस दे आर देयर, ओके. So there is no roadmap to destroy those banks of ozone depleting substances जो हम ऑलरेडी प्रोड्यूस कर चुके हैं, जो बैंक्स ऑलरेडी मौजूद हैं, उसको डिस्ट्रॉय करने के लिए this protocol is silent. There is no clause relating to the banks of ozone depleting substances, and it only addresses the production of the new ozone depleting substances or the consumption of the ozone depleting substances. Yes, Nikhil.
But if we want ozone layer to recover completely, then we must stop even using the refrigerators and all that petroleum products and everything, coal.
Nikhil, we cannot stop using the refrigerators. So what science is doing, science is searching for the alternatives. See, for the CFCs, we have other alternatives. Okay, we will see. After the CFCs, we have the HCFCs. Okay, and after the HCFCs, we have these HFCs. So science, it is always for the alternatives. Science always discovers the alternatives. Nandini, no need to worry, I will explain it. See, the Montreal Protocol, it is the first binding legal agreement for the phasing out of ozone depleting substances so that the ozone layer can recover. And this Montreal Protocol, it is also universally ratified. People, yes, the Montreal Protocol, it also covers the HCFCs. HCFCs are also covered under the Montreal Protocol. So Nandini, I was telling that this Montreal Protocol, this is a legally binding agreement with binding targets on the developing countries and the developed countries as well. And this was entered into force in 1989. And under this treaty, the production and the consumption of the ozone depleting substances, the new production, industrially, there is some limitation on the production of the ozone depleting substances, and also the industry cannot consume the ozone depleting substances. So there is a phase out plan for both the production and the consumption of the ozone depleting substances. And this treaty was very, very successful, and ozone hole has shown signs of recovery. Okay, and it is estimated that by 2050, the ozone layer, it will recover itself. Okay, so this was a very successful treaty, and its one major drawback is that it is silent on the destruction of the banks of the ozone depleting substances. The ozone depleting substances that we have already produced through the industrial process. What will happen to the existing banks of ODS? So this treaty is silent on that part. जो भी हमने devices produce किए हैं, refrigerator, be it ACs or be it any other electronic equipment where the CFCs are used. So those discarded sources of CFCs, they still have these CFCs. Kritika, what exactly do you want to ask? Consumption is being taken under the treaty.
So you
See,
said that treaty is not showing any, has not any steps to eliminate the existing ODS,
existing
but it
banks.
is controlling the consumption. So it is not affecting the environment as such, right?
The existing bank of ODS, they will affect the environment because CFCs, they are volatile. They will escape from their sources. Okay, there is limitation on the consumption of CFCs. As per this treaty, see, if previously you were using the 100 units of CFCs, then you can use only 20. This is just an example. Yes, Aman. Existing means which has been already produced and which exists. Okay. Okay, Kritika, very good. No, Saloni, the CFCs, they are harming the environment. What we are doing it, कि जो गलती पहले हो गई उसको सुधार रहे हैं, नया प्रोड्यूस नहीं कर रहे हैं. We are making sure that no new CFCs are produced. Okay, the industrial manufacturing of the CFCs, it should stop. What has already been produced, okay, we will see it later what will happen to that. But first, let us stop the production of the CFCs. So it is targeting the production of new CFCs. Industry cannot produce new CFCs. See, there is a difference between convention . The convention is a larger framework with broad guidelines. Convention is a larger framework with broad guidelines. And in case of protocol involves the details. Okay, protocol consists of specific guidelines. So the convention is a broader term and protocol, it is more specific. So the CFCs, they are mostly phased out. By the 1995, the developed countries, they phased out the production of CFCs. We will see it, don't worry. What exactly has been done to reduce its production? See, the governments, they generally ban now the CFCs, they cannot be produced. Neither the industry users, they cannot use the CFCs. Such kind of bans are there. Or you cannot import or export in the CFCs. See, the AC, the use of ACs have increased, but the manufacturers of ACs, okay, they are using the alternatives to CFCs. Like, see, we have another very good example. All of you must be knowing that in April, the BS4 vehicles, the sale of the BS4 vehicles and the registration of the BS4 vehicles, we have banned it. So what the industry has done, the automobile industry has done, they have shifted to BS6. And in order to shift to BS6, they have to modify their engines. And the auto industry, they have modified their engines. Okay, they have discarded the BS4 technology. So there will always be alternatives. We are using the alternatives to the CFCs. The refrigerators, they are there to stay. The ACs, they will be there because we need them. So that is all for now. We will continue from here tomorrow. And I hope everything is very clear to you. और अगर कुछ डाउट्स हैं तो प्लीज मुझे आप बताएं, ठीक है? ऐसे आगे बढ़ना ठीक नहीं है. समझ में आना चाहिए. एक बार समझ में आ गया तो फिर चीजें एक लंबे ड्यूरेशन के लिए याद में रहती हैं. और अल्टीमेट एम इज टू मेमोराइज थिंग्स. और समझ के मेमोराइज करेंगे तो रिटेंशन थोड़ी लंबी होगी. ओके, और उसके बाद जब रिवीजन करेंगे तो उस रिवीजन में आप जल्दी थोड़े समय में उसको ग्रैस्प कर लेंगे. Okay guys, thank you from my side and see you tomorrow.